Hey everybody, welcome to Dev Better. This is a series where we talk about software engineering concerns and issues that we've encountered during our travels as a software engineering consultancy, and give back to the community some of the ideas that we believe were interesting and valid, and also just produce some dialogue around hard problems. Because there's a lot of hard problems in what we do and our jobs are difficult. So we would like today to discuss infrastructure as code and how we continuously deliver that into a cloud platform. The most important thing to remember, this is not a commercial. Any of the technologies that you hear on this are things that we like and that we have used and that we enjoy and we think are good technologies, but all of these concepts will apply to your target environment just as well as they would ours, as opposed to selecting the target tool. With that, let's introduce the engineers in the crew today. So let's go around the room real quick.
Hi, my name is Chris. I've been a software engineer with 7Factor for 4 years, and I work primarily with a lot of our DevOps tooling and solutions from Concourse to Terraform and AWS and all the things that we'll be talking about.
Cool. Jeremy?
Hey, my name is Jeremy. I've been an engineer at 7Factor for about 9 months, and I've been learning a lot about the DevOps side of things that we do here, and been seeing a lot of cool things.
Nice. Thanks, guys. Let's first talk about the problem we're trying to solve. Continuous delivery of infrastructure is something that has been conceived for a while now. You think back to the days of Spinnaker, if anyone's used Spinnaker. There's also a lot of new frameworks out there that people are trying to invent, kind of this PaaS approach to continuous delivery of infrastructure utilizing something like Terraform underneath the hood. I know of a couple of startups actually here in Atlanta, one actually that's doing this, and they're building products on top of this concept. We also have Atlantis, which is this automatic magic Terraform running thing that you can install on your network. You can sort of tool Jenkins to do this. Like, there's a million solutions to the problem, but let's really talk about the reason that we want to do continuous delivery of infrastructure. The first thing that comes to mind is that you want ephemeral environments. Remember that a cloud is not the same thing as your on-prem data center. On-prem data centers are babysat by people where you have to log in and do patching, or maybe you have an Ansible instance to do your automatic patching, or maybe some other fancy way of doing it. But at the end of the day, those servers are considered to stick around for a very, very long time. And they require watering and feeding and caring for. Whereas in the cloud, there's a bit of a departure from that concept. Instead of sitting around and running, having these machines run for a very long period of time, we sort of expect them to die at any point. And sort of one of the underpinnings of the Amazon shared responsibility model is that, yeah, we can die. Like, our machines can break, and it's up to you, client, customer, person using AWS, to be able to recover from some of those situations. And this is where continuous delivery of infrastructure really shines, and it's something that we can use to help ensure that we have what's called ephemeral cloud environments. In other words, at any given point in time, I don't care if I lose a piece of my cloud infrastructure. Now, that has software engineering implications. You have to make sure that you're designing your applications in a way that they are fault tolerant and they can come back from the dead if they're killed for some reason, along with a bunch of other concepts that we're not really going to cover here, like 12-factor wrap, environment-based configurations. These are all really good things that will help you get to that point. But from our perspective, we started doing continuous delivery of infrastructure really at the very beginning of the company. When we started, it was just me and a couple of other folks, and one of the things I really wanted out of my engagements with my customers was to be able to deliver software really quickly into their environments using these continuous delivery ideas that you've heard out there, right? Continuous integration, continuous delivery, fast feedback loops, Kanban system, all that kind of stuff are things that we want to be able to do. So very early on, we started looking into how do we do this in a way that allows us to get infrastructure out and maintain it and make changes to it without having to go in and on my laptop run Terraform apply, which is just a horrible, horrible thing to do if you've ever done that before. So we picked two things to do this with. One is Concourse, which is a continuous thing doer, which we'll discuss in a moment, and also Terraform, which is a very well-known platform for creating infrastructure and pushing it out to various environments. I think let's go to Chris to talk about Concourse and Terraform. I'd love for you to explain those ideas.
So I'll just give a very brief overview of Terraform. I'll start with that because I think it'll make more sense. So Terraform is, I like to think of it as our screwdriver in the situation. It is the tool that gives us easier ability to create our resources in Amazon. We didn't need Terraform to do it. We can already call those APIs otherwise, but Terraform, of course, gives us a ton of controls over that situation and many other big wins there. So Terraform was our solution for wrangling the beast that is AWS. But it's still a tool, and that brings its own set of problems. And the tool itself has to be automated in some fashion. Even though it is automating those API calls, now there's one step further, that the Terraform is now effectively a script that has to be ran. Who's going to run it? And as Jeremy Duvall just mentioned, in ideal situations, you as the human developer do not want to be running Terraform manually. It's just too much effort and maintenance, and you're going to end up with a bad time. So have a computer run it. And which CI tool are we going to pick? There's Jenkins and Circle, and there's so many, right? So why do we pick Concourse? And we picked Concourse because as it's self-described, continuous thing doer, which is very vague on purpose. It's effectively designed as a script runner. And it is containerized, which is not a necessarily unique thing among CI platforms. Again, there is Circle, which is also a containerized CI platform. But Concourse for us was just bare bones enough. It was simple. It gave us a nice pipeline to push containers through. And it just, especially in regards to Terraform, we get to take a container that has Terraform pre-installed on it, and run that container with the script inside it to say Terraform apply whichever configuration we're trying to apply. And it was just very simple to set up. And, we don't have to worry about Terraform versions or anything like that, because the particular version for that, it's always downloaded every single time fresh. So we can change versions whenever on the fly. And yeah, it just was a pretty simple, straightforward solution.
Right. And I think at the time, Concourse was one of the few containerized CI systems when I was looking. This was like 4 or 5 years ago, right? And this was Drone. I think Drone was containerized at the point, but Drone is sort of very shortly thereafter became defunct. I actually think it's back. I haven't looked into that at all. But at the time, it was very appealing to us because we were able to create these environments, like Chris said, inside a container that had everything it needed to run the appropriate scripts. That's one of the challenges with Jenkins, and one of the reasons why containerized CI has been a thing is because you don't want your Jenkins servers to snowflake. And that concept of snowflaking is they sort of drift out of configuration, out of a static configuration. Anybody that's managed a server farm has dealt with drift before, and things like Ansible and Puppet and Chef are designed to solve for this configuration drift problem. And CI servers were kind of neglected in that way, and that no one really worried about your CI plugins drifting on your Jenkins instances, and now all of a sudden half your CI is down because you have an old version of a plugin that runs Gradle or something crazy like that. So we liked the idea of containerized CI because it provided a foundation in which we could control the environment inside of which a certain thing was ran. And this also applies to the other CI concepts in our pipelines, like running unit tests and building your app and creating containers. But for Terraform, it kind of made sense for us because the plugin system in Terraform, you want to make sure you have everything just right, because if it's not just right, you could run into some serious provider template issues, which we have actually seen and had to fix before, and that's been fun. And Jeremy can talk about that later if we get there. But yeah, so the solution that we used to deliver Terraform, or to run Terraform to deliver our infrastructure into the cloud, was simply Terraform running on a container instance using a very well-known container instance in the Concourse world, LJ Franklin. He had a really cool Terraform container that he's built. It's a fantastic. Highly recommend that you check it out if you're running if you're running Concourse and you want to get into kind of continuous delivery of infrastructure. It does pretty much everything you want it. We've seen it go from being an adequate solution to now it's a very, very robust, good way to do that. It supports plans now. It does all kinds of cool stuff. At one point, we had to create our own custom container because it didn't support IAM roles. Like, there's all kinds of crazy stuff that have gone on in the Concourse world that has made this even better than it was before. But the concept of let's take a check-in, like say we have an ECS cluster and we want to modify the number of instances in that because we're not in Fargate. We want to sort of manage our own costs, which again, Fargate's expensive, and if I run my own servers, it will be cheaper. So I want to manage my own costs, and I want to sort of put a control set around checking in a scaling event for going from 5 instances to 6. The way we do that is we have every single piece of Terraform is in GitHub. All of that is defined. We choose to use modules to define certain blocks of infrastructure, which goes into Terraform theory, of which there's a lot of information on the internet, some of it probably better than others. We choose to make little blocks of functions that perform a job, sort of like a functional programming approach to how you do Terraform. And let's say that we check in into our repository that I want to go from 5 to 6. That can go through an approval process. Everyone can sign off on that and say, yeah, that's good. You changed one line, looks good to me. And then we check that in. That runs through the Concourse pipeline and eventually gets pushed out into the cloud with little to no intervention from humans, which is fantastic because I am not, again, like Chris said, running Terraform apply and potentially breaking everything because I forgot to pick the certain workspace in Terraform that aligns to the changes I'm making. So it drastically reduces the problems, the error proneness that you see with Terraform, which I honestly think is a reason people have not used Terraform more often, is there's just so many issues with running it manually that it just causes tons of problems. So next, let's go into the pros and cons. So this is kind of the meat. We've described the problem. We've discussed how we did it in kind of a vague way. But I really want to talk through the lessons learned that we've had from choosing to do this. And that's anything from choosing to do infrastructure as code and pushing things into various cloud environments automatically to the tooling that we have chosen. So let's go around the room real quick. Let's start with Chris. And here's the question. Talk to me about some of the advantages that we have seen when we're working with clients and we're using continuous delivery of infrastructure into Amazon specifically. Because Azure is a different question. We use ARM templates for that, which is a wholly different conversation.
I think one of the first biggest advantages I can think of is our speed of deployment, and especially that first initial deployment. When we set up new clients and get clients set up with brand new Amazon accounts and brand new networking stacks and VMs and just building out their whole infrastructure, it can sometimes take us, just a matter of a couple of days or less, which should not be taken for granted. I mean, on the one hand, it is what AWS has been designing for and wants all of its users to get to, but it's not something that necessarily everyone has gotten to. And not to gloat too much, but we have gotten to a point where we can, this networking stack and this full Amazon that we're building out is PCI compliant, HIPAA compliant, SOC, and every other type of compliancy. We have our databases behind at least 2 layers of firewalls. I mean, it's a robust production ready environment. And we do that all through the power of Terraform. If I had to sit down and count out the number of button clicks and form entries that you would have to do if you did that through the console, God forbid, or maybe if you did that through some CLI commands, what have you. Well, Terraform is doing all that and more. So huge advantage there for speed of delivery. Also, of course, the error rate, because Terraform is a script. So how often is it going to error? Well, in theory, 0. It's going to do the thing that it does it's idempotent, incredibly idempotent, but one of the most idempotent tools I have ever used. So yeah, those are some of the big pros I can think of there.
Yeah, and to piggyback on something that you said, when you segment out your infrastructure and you let your experts who are really good at certain slices define what that looks like, and then you can continuously deliver that without really having to dig into it. It's a huge advantage. Going back to what you mentioned about HIPAA PCI compliant networks, I wrote that module for us, and I have a lot of experience developing very robust networking stacks that are secure and designed with the appropriate public-private subnet pairs. And so me having that experience and being able to provide that back to the broader team, now all of our company, all 56 engineers, have access to a set of code that they can call that they know creates an appropriate networking stack with the correct number of private public subnet pairs, and they don't have to think about that. And that's important to be able to provide those building blocks, those Lego bricks, to the rest of your team in a meaningful way. So Jeremy, what about you? What do you think are some pros of doing it this way?
Yeah, this is rather timely because I am in the middle of doing this for the first time, using these scripts that you're talking about to set up a new client's initial infrastructure, and it is really, really nice to be able to have, there's a thing to initialize our IAM roles and to set up the ECR repositories and the ECS clusters and all the networking. And if I had to do this myself with especially the networking part, that's never been my strength. And so I'd be struggling left and right. But because Jeremy made this module, I don't have to think about it very much. There's a networking module, load it up, make a few changes, and it's good to go. We have changed our practices over time, and so some of it as a module is perhaps not up to date, but that again is super easy to change because it's just a couple of tweaks here and there, and then you have this really nice networking stack that's just ready to go.
Right, and you can roll that out pretty much everywhere, which is its own set of challenges. I think that's one annoyance which is our next question. What's something that we think we can improve in this process is, specifically around our module versioning system, we need to get better about how to statically set modules at target versions, which is really easy to do in Terraform. It's not even hard. It's just a process that we've not put in place yet. So if I make a change to that networking module and I want to roll it, so for example, I added patching to the networking module where the Amazon SSM system will come in and patch the Bastion hosts, which are a part of the networking module. You can say, I want 2 or 3 Bastion hosts, and it will create them for you. In order to set up patching for that, I rolled that out, and it went to everybody. So it's like, well, what if I didn't want patching, right? So setting up the appropriate versioning is, I think, a challenge for us and something we need to work on top of making sure that Concourse is up to date and running the right container versions, which we've seen some challenges too as well. But I kind of jumped ahead a little bit, so let's kind of ask the question and go to you guys for the same answers. What are some problems with the implementation that we've done, and what do you think we could do to solve for those?
I'll take this first. This exact thing, these modules. Like I said, there's some changes that are being made, and when we're using Concourse, we set up these all of our Concourse jobs and these pipelines to look at directories in a repo that if it sees a change, then it will make the change, and here we got a new version deployed without much intervention from a human. But as J-Dub said, he made this this networking module, made a change to it, that the repository where that module lives isn't tracked by a lot of these Concourse jobs. And so that's one of the problems that we face. That change is there, and it will be picked up the next time you run the Terraform job for the networking module. But if you don't run it, then you don't get those changes, and you may not even realize they're there.
Yeah.
And so that's one of the problems we're facing.
Yeah, that's a really good call out, and I wish there was an easy way to solve for that didn't include spidering, Concourse triggers across 15 different repos, which you could do. We could go in and set up links to all of those modules downstream, and when it picked up a change, it knew to go and run this. That would be a nightmare, right? That would be so just blah. It just feels blah. Chris, what do you think?
Another one that I could think of is our testing solution. Admittedly, is deploy it and run it and
come on, what's your problem?
Unfortunately, it's I mean, at least we don't do it in production. We obviously do it in a pre-prod environment. But yeah, anyone who's worked with Terraform before probably knows that testing Terraform is very challenging. It's I mean, in the traditional sense, you can't create these resources locally. There is something called local stack, which is I believe it's open source, but it's a Docker Compose based project that you can pull down, and it's supposed to come with essentially mock containers for each of the various AWS services, because of course when you're testing, you just want to know like the S3 bucket, does it work? But yeah, testing that your Terraform has created the resources that you wanted it to create with the configurations that you intended it for it to create. The only real way that you can do that is to literally do that, which in the case of services like S3 or IAM is several seconds, which is kind of long for testing, but not super long. Now, if you're talking about RDS, which could be 10 to 15 minutes to wait for that to spin up and verify, now that becomes a lot more painful to test. So we have tried this and we did not finish the project, but the idea that we were going down with Terraform testing was to use this framework. Remind me what it was called again?
Quick.
It was a Ruby gem, AWS spec.
Yeah,
I believe it was in conjunction with Kitchen. But anyways, the point is essentially you would run a module to build the things that the module would build. You would run some very quick assertions like ASG has one instance in it, or has whatever. You just check a couple things, and then you could delete it when it was done. And even if it took a while, that whole process could be automated. So it is a little bit clunky, but we thought the idea was neat, and the end of it would be to not only build and test that first module, but to actually build and test all of our basic cloud modules in a sequence, to start with the VPC module, and then the ECS cluster and the ECR, and basically build out that whole infra, test it, and then knock it all down. And even if that took 30, 40 minutes, it would be cool to test and prove out that, a full, environment can be built out that way, and that our Terraform modules do what we say they can do.
Right. And there's a few other frameworks like inspec and some other things that will allow you to inspect what's going on with your Amazon and how the Terraform runs. And I actually gave a talk at a local code camp here in Atlanta on using test-driven development to do to build Terraform. I had like 4 people show up, so it's one of those things that I don't think a lot of people care about, which is kind of sad to me, because Terraform and other scripting-based languages are such a cool way to interact with your cloud platform, right? And it gets you, basically, you can start designing infrastructure the way you design software. And this is why DevOps was such a huge thing for our industry. I mean, DevOps, by the way, is a movement. It's not a set of tools. There's a bunch of philosophies behind DevOps that are very important for people to learn and understand. But that movement made it such that operations became a software engineering effort, as opposed to it being folks, running through their Jenkins farms and kind of typing in things and, moving servers and SSHing into stuff and installing things, thanks to the cloud and to things like Terraform and CloudFormation, even though we don't really like CloudFormation for many reasons, and ARM templates on the Azure side. Those things have created an ecosystem where we can treat infrastructure as a software engineering exercise. And that's really cool. And that means we can get things like testing now. Whereas most folks will just remote into the machine and make sure it has Apache installed, right? And or they use Chef or Puppet to create recipes, or they use inspec to do an RSpec based assertion on some real server that's running out there. So I think we're in a really cool spot in software engineering. Again, it's more work for us, right? Software engineers have to do everything these days. We have to QA our own stuff. We have to DevOps our own stuff. And there's a lot of work and a lot of knowledge that's required for us to do our jobs efficiently. But I think infrastructure as code has been a really cool thing for us to explore as a company. And I also think it's added an incredible amount of value to the clients that we work with, and also in our own internal stuff for the apps that we've built for folks that are out there on the market. So thanks guys. I really appreciate you guys joining me. Thanks for everybody that's watching this. Again, the whole point of this is to just explore the problem and discuss some of the solutions that we've seen. I really hope that infrastructure as code is something that you guys are thinking about out there in the ether. It's very important in a really cool way of deploying your infrastructure, but there are some prerequisites and some interesting things you kind of have to think about. This is us sort of scratching the surface. If there's any interest in us digging a little deeper and maybe doing some more deep dives into what we've done, we're more than happy to get that out there, and just let us know if that's something that folks are interested in. Other than that, this has been Dev Better. We appreciate everybody. Thank you guys for watching, and have a good rest of your day.